It's quite a cold but crispy outside. I think it is very good, condition for producing ozone outside. You guys may smell some fresh fish smell. I don't even know a fresh fish smell. Do you know that? Well, you may heard fish is kind of rotten smell, although, but well, I can say fresh fish smell. Just have some fishing and take a fish and smell it. It is just like the ozone smell. But the important thing is the odor from fish is not reacted, but very similar smell, ozone smell, which is very reacted, and it can irritate you actually. The difference. All right. Well, we actually finished chapter 2, and now is the time to solve the real world, significant environmental problems. Well, what kind of environmental problems can you guys have in mind? What is the most significant environmental? Problems. What do you think about this?
Environmental problem.
Yeah, what is the most significant environmental problem, as your opinion? What could it be? Just give me a guess.
Lighting. UV.
UV is not the environmental problem. It is kind of factor that cause environmental problem, right? So what is it?
Ozone layer.
Ozone layer destruction, right? At the here?
Oh.
All right. So is that right? Ozone is two types of ozone. One thing is good ozone, and the other one is bad ozone, right? So you care about the destruction of ozone layer. That means the ozone there, you mean sky, that is very good ozone because you care about that, right? What about the ozone here? I mean troposphere, atmosphere. Is it good? Bad as a liquid, right? So it is just like the hydroxyl and nitrate. It can cause you a kind of very not bad health problem. And also, what kind of environmental problem can you think of? Well, this is he just introduced the right one. I want to explain it right here today. Well, this is related air environmental, atmospheric environmental problem, right? What else can we get in the air? Adhika. What
Global warming.
Global warming. Yeah, that is very significant and important. Nowadays, most of the people care about that, and also even the for the people on the earth, they want to make money to deal with that. That is very, very important. And also, there are many different types of environmental problems in the water and in the soil, and also even marine environment. But most of the significant environmental problems we are carrying is mostly related to atmosphere. This is very, very important. So, we'd like to know some atmospheric chemistry, atmospheric molecular chemistry. This is very, very important. All right. Before starting, well, actually, the first topic is the light. Well, if you read the book Genesis, well, actually the Bible Genesis, what is the first thing that God made?
The light.
That is right. So the God just talk to the word. There will be the light. So the light. So the light actually the power of everything. It can cause problem, and it can give any good things to you. Right? Without the light, we actually cannot survive. Right? Well, this is kind of theoretical side of the light, but based on the science, well, we can categorize actually several reasons of this light of the electromagnetic using the electromagnetic spectrum in order to decrease energy. Well, there are several categories: X-rays, ultraviolet, UV, and visible. Now we are seeing in the atmosphere and infrared and microwave. Well, you guys heard about the microwave, right? Microwave oven. Right? So what is the mechanism of the microwave oven? You just put this cold coffee inside the microwave oven. What happens is, if you just turn on the microwave and wait maybe a couple of seconds, you can have very hot coffee. What make this cold coffee hot? Microwave, right? So what is the reaction mechanism? Yes, here. Well, actually, microwave can vibrate molecules. So the vibration energy actually converted to the the heat energy. So if you just put your hand inside the microwave and turn it on, what happens is the molecules of your flesh actually heat it up. So you can have very nice steak of your body. This is just kid. I really don't know. You guys enjoy the United States drama X-File. Have you ever watched the X-File before? No. Maybe X-File is kind of out of date, TV drama. Maybe when I was college student, it was very popular here. The first episode is some very bad guy actually made the microwave. Well, the size of the microwave is just like this room, and at the center they just put it the microwave source, and then put the people inside here, and turn the microwave, and all the people. So some people actually they call the police. This is done by ET actually, not the people here. But murder and Scully actually found out those are actually done by the very bad guys, not the ETs. And the microwave is kind of very long wavelengths. It is 0.1 to 100 centimeter. Very long wave, right? 1 meter lengths. And the next one is infrared. We call it IR, and which is 2.5 to 50 micrometer. This also can convert it to the heat. Actually, this is caused by the molecular vibrations. Actually, this is molecular rotation, which is very similar to that. And then the next is shorter. Right is visible. The lights we are seeing right here, which wavelength is 400 to 700 nanometer. Actually, it can be used using hitting the valence electrons. Actually, we cannot get visible light in the heat from this visible light. And the next one, shorter one, is UV, ultraviolet, which is 100 to 400 nanometer. And also the shortest is X-rays, 0.01 to 100 angstrom. So why these are so dangerous? Well, you may want to have X-ray if you have some suspicions on if you have some kind of bronchitis, you want to check your lung with the X-rays, right? But the important thing is, whenever you have X-ray exam, the doctors actually give some kind of very special notice. Don't put the necklace, or you need to protect it by wearing the clothes, right? So why? X-ray itself can cause affect inner electrons. It can severely damage the structure of the electrons, maybe your body. So it can cause kind of cancer. Ultraviolet, this is the same thing, 100 to 400 nanometer. So this is the reason why we want to wear some cosmetics to protect your body skin, actually. And also, there is a very significant equation to explain the relationship between energy and wavelength. Actually, this equation was derived by this famous quantum, I cannot say quantum physics, but somebody say chemist, somebody say physicist. Do you know his name? Here.
Max Planck.
Okay, can you over there? Can you talk it louder here?
Yeah, his name is Max Planck.
Yes, Max Planck, right? Max Planck. Well, Max Planck is he German or is he French? German, right? Maybe from this photograph you can guess he kind of was born around the early 1910 or 1890, like that, right? So he went through World War I or World War II. So was he Hitler's side or was he anti-Hitler's side? This is very, very important to you guys. Or is he Stalin's side?
I'm neutral in terms of findings almost finding.
So you think he don't want to get involved in any politics, right?
Yeah.
Yeah, right. Actually, he's a very nice guy. He actually found Albert, the stupid Albert, Einstein, actually, and Switzerland. Yeah. Well, at that time, he is a professor from the 1920s, and Albert Einstein was a very stupid graduate student at Switzerland. He found him, and he taught him, and he encouraged him to be a wonderful and famous physicist. Well, he introduced some kind of quantum physics. So some people say he is introducer of the quantum physics, and also somebody say he is the greatest contributor of the quantum physics actually. But the important thing is, Max Planck himself actually has very strong suspicions on the quantum physics. So he never ever have used quantum physics for proving his theory. It is interesting, right? He gave significant contribution to quantum physics, but he didn't use it. Wow. What do you think about this? Well, you're the professor when you get back to your country, and you raise your student, and you think you gave him encouragement, and he be a very famous professor like you, but you never ever use him, for good, for involving your research work. Is it possible?
I heard that Einstein did the same thing.
Yeah. Why?
He did not actually believe that the quantum physics or something like that is real, but he made a significant contribution on that. I heard.
So why is that? Is it just like he is just in love to solve this curiosity? Is that it? And some stupid, followers just to use his theory. At least I believe in my students. I usually give very strong credits on them. Well, anyway, I really don't know. And also, he is kind of very anti-side of Hitler. So he said many Jew scientists actually. Well, anyway, he gave a significant contribution on quantum physics actually. Well, anyway, there is very famous research institute in Germany nowadays. Have you heard about the Max Planck Institute? There are many branches. Very big, actually. To be a researcher is very, very difficult. To be a professor at least is also difficult. So he just described the relation between energy and wavelength. Energy equals nu, Korean H. Well, German H is ha. What is the French H? How do you pronounce it? H. H. Great. Nu. So here, H is Planck's constant, which is 6.63 times 10 to the 34 joule-second molecules. You really need to notice this is a molecule. So you need to use molecular concentration when you want to use this value. And the energy is also in joule. Nu is frequency of the light in second. And this can be described by the speed of light divided by a wavelength. You guys know the speed of light is 3 times 10 to 8 meters per second, and the wavelength in the unit of meters. So now you can use this equation to convert from the wavelength to energy. Here is one sample question. Well, actually, you want to, well, oxygen bond is kind of, is not that, you know, we just want to destroy and divide oxygen molecule to oxygen atom. Well, here, in this case, what kind of light we need to use to degrade or to destroy oxygen molecule to oxygen atom? Well, you guys know X-ray and UV, the shorter light has higher energy. If you use this equation, the relationship, we can easily solve the problem. Here, the energy of oxygen to oxygen bond is actually O2 is 4.92 times 10 to 5 joule per mole. What is the maximum wavelength of the light? So what light can you use to break this bond? Well, just to calculate the wavelength so that we can choose which light we can use to destroy the oxygen molecule. So here, just to put it the max Planck constant, then we can put it here, put the speed of light here, 3 times 10 to 8. Then divided by the energy. The important thing is, as I already told, you guys are using Planck constant in molecule. You need to multiply the concentration here. Avogadro's number. One more, 6 times 10 to 23 molecules. And then you want to convert it to meter to nanometer, right? And then here's 243 nanometer actually popped out. You guys know this is in the range of UV light. So you need to use UV light less than 243 nanometer. And also you can use X-ray to destroy the oxygen molecule to oxygen atom. But you cannot use it. You cannot use infrared or microwave. So the molecule cannot be broken. And also, this UV light cannot reach actually the surface of the Earth, which is very, important thing to us, right? Okay, most of you already have this information when you were middle school or you were in high school, geoscience class actually. We just want to talk about the atmospheric structure. You guys know there is atmosphere or troposphere, then there is stratosphere and mesosphere and thermosphere, right? But the important thing is, at least you need to know the temperature and pressure change, in the this structure of the air. And also, important thing is, as an environmental scientist, we just care about the troposphere and also stratosphere. This is what we want to know as an environmental scientist. Well, mesosphere and thermosphere, well, I really don't know. It can cause very significant effect. Maybe, you guys find the ET, well, those can actually cause our environmental problem. But right now, most of the environmental problem actually start from stratosphere and this troposphere, right? Well, here, troposphere, yeah, troposphere. You guys know the temperature and pressure of the Earth's atmosphere changes functional altitude. Here, altitude. This is just a normal units. And this is pressure. We just put it natural low here because the pressure actually exponentially decreases with respect to pressure. So we need to put the log here so that we can have kind of linearized relations here. All right. The first time, you guys can see a troposphere here around the 50 kilo. So from the Earth's surface to about 50 kilo in height, the temperature actually dropped, 6.5 Kelvin per kilometer. This is important. And also from here, 15 kilo, the temperature and also start to increase. Actually, stratosphere. So this altitude we call it tropopause. Altitude pose, tropopause, and the area, the zone between the surface and this tropopause we call troposphere. Well, you may heard about the atmosphere, right? But as an atmospheric chemist or environmental atmospheric scientist, we'd better call it troposphere. Troposphere is right now. Right. And then the temperature increase continues from the troposphere. Well, actually here you can see the temperature rising around the 50. So, and this altitude, we call it stratosphere, stratopause, and the zone between the stratopause and tropopause, we call it stratosphere. This is very, very important. And also, the pressure actually exponentially decreases throughout the atmospheric heights. Well, as a way of mesosphere and thermosphere, these also exist here, but this is not our interest. And one more thing we need to notice is the three reasons on the Earth. Well, Earth actually rotates, and also because we have warm equatorial here and cool polar area here, well, actually the air actually moves through the atmosphere and through the sky. So the atmosphere divides actually 6 reasons. This is just a northern part, and the southern part we have 3 more. This atmospheric reason, well, here we call it polar, and the middle we call it federal, and here we call it hadal. So polar, federal, and hadal cells, we call it the low cells. This division of atmosphere tend to slowly mix each other. So the contaminants protons can be mixed each other. Here, as you can see, sometimes the contaminants emitted from one area, it takes several years for protons, fully mixed around the southern and northern part of each other. So because the Earth rotates and the different temperature, the contaminants can be mixed up each side. As a way here, maybe some kind of pesticide spray during the springtime on the field of the cotton in the United States, and this can be easily transported, and then it can reach on the polar area, and the polar bear can be contaminated by these chemicals. So polar bear actually cannot produce those toxic chemicals for themselves, and also they don't have any intent to use it for killing themselves. All right. Some student here actually answered. Ozone is very significant contaminants, actually, which can cause significant environmental problems, called ozone hole. And also, some student explains the global warming as kind of a very significant problem. So think about this. Anika actually, told global warming is a very significant problem. So global warming itself, actually, we can have much higher temperature in winter time, right? But in Korea, actually, this is not that higher temperature. So can you say this is global warming? Well, we can have kind of very hotter summer, maybe a couple of years before. But what about the lower temperature during the winter time? Is it related to global warming? We better say global, temperature decrease. So why what is the right term to explain much more colder, cold, temperature in winter? Yeah. So global warming is kind of, one specific environmental problem. We'd better call it climate change. So climate change problem. Global warming is one branch problem of climate change. So you really need to know about this. All right. From now on, I really want to talk about the very significant environmental problem, ozone depletion in stratosphere. Is that right, Tom? If you just cut your arm and then put it in microwave and turn it on, what happens is you can have very well done your ham steak, right? But what if there's no, ozone in stratosphere? So the sun actually emits a bunch of X-rays. X-rays cannot reach, I really don't know, but it cannot reach Mars. It cannot reach Venus actually. So we don't have to worry about the X-rays, right? But what about the UV? If we don't have enough concentration of ozone, what happens is UV actually just penetrate the stratosphere and also troposphere and attack your skin actually. You really don't have any idea about this. The UV cream cannot protect it. Under the proper concentration of ozone in the stratosphere, you can use UV cream very effectively. If you don't have it, well, what you should do is Woojin, understand my question?
Not sure.
Hyuna, what do you think about this? What do you want to do? If the Led Zeppelin song, "Thank You." There is some kind of lyrics like this. If the sun refused to shine, something like that. But the sun never ever, refused to shine in your lifetime. So what you should do is just dig the ground. Hide yourself. That is what you should do for your survivor. That's it. Right? So this is the reason why we need to know the ozone depletion mechanism, so that we want to prevent the depletion of ozone. If we don't know this, we actually can do very stupid thing to produce CFCs, which can accelerate the depletion of ozone. Because 3 Nobel Prize winners, they actually explain the reaction mechanism. The governments of the Earth can stop the producing of CFC. So now, what do you say to me? If you really want to make such kind of environmental policy so that you want to save the Earth, I really want to recommend you to run science at first. Just don't talk to me, I want to go to UN after having undergraduate study. That is very stupid thing. If you go to the UN after graduation of college, you are just the one of the key, not key, just one machine part. If you really want to be, to contribute, for sake of the Earth, the first time, run and study very hard environmental science, and be a master and doctor, and do more research work, and find out the very basic, chemical reaction mechanism, and then explain it all of the people on the Earth. And those reaction mechanism, those theory can save the life of all humankind here. That is what you should do. I really recommend this. If you just graduate and then want to go to the UN office, well, I don't think that you can be contribute significantly. You can be just a bureaucrat. That's it. You just ended up like that. I really mean that, Michael. That is very, very serious. Because most of the KAIST, student here want to be at the, president or vice secretary of UN, just like the Mr. Kim Ban. Well, he is kind of very exceptional in your case. But be a scientist. And be a good scientist. Be just like Max Planck. That is very, very important, If he is side of the Hitler, we cannot imagine the evil actually. He may make atomic bomb, Well, anyway. So from now on, you guys will learn how the ozone can be depleted. Here, ozone is light blue gas. Well, if you can ask me, can you see the ozone and can you see the color of ozone? Well, frankly, I smell it. I smell it. When I was a graduate student, because I have used ozone for the treatment, of mechanical contaminants. But I can smell it, but I never ever seen the color of ozone before. But from heights, it is light blue color gas. So maybe in high concentration, ozone can be seen as blue color gas, actually. the boiling point is around the minus 110 Celsius degree, and it has a kind of unique electric. I really don't know electric smell, but I already told you it is fresh fish oil, and it's highly electric. Its structure is 3 oxygen here, in a single bond, bring together in the shape of U. This is actually like U, just like this. And the bond angle is 127 degrees. This is very, very important. Undergraduate level, environmental chemistry and environmental science is not that, deep and difficult. But if you want to have interest, want to go to the graduate school, the structure of chemical is very, very important. And also, this is very, very important characteristic of ozone. Ozone can absorb UV light in the range of 200 to 30 nanometer, so it can protect you, right? So here, absorb, there is 2 terms. What is the difference between AB absorb and AB adsorb? Again, can you differentiate? This sponge, if you just put a sponge into the water and this coffee, sponge can suck up the coffee, right? Is it absorption or adsorption? Why? Tell you. Yeah. What do you think of this?
Sponge is suction is sorry.
Absorb.
Yeah, absorb.
AB salt. Absorb.
Yeah.
Why?
Because that's the meaning of that term.
What is AB adsorb? Why coffee cannot be adsorb on sponge? Because the meaning adsorb itself,
Yes.
is different, right? Sam, what do you feel?
I agree with.
All right. Hyobini. You're just talking. Well, this is actually enjoy the show class. But if you have very, important thing, you may have, exam next, class. If so, please don't come here. Go library, and have class. Don't have class, and prepare exam. I really mean that. You enjoy here, but never ever, do anything not related with my lecture. I really mean that. That means you should be focusing on my question, and you should be enjoying my lecture, right? Okay, I think time is up, and this is for today. Well, I think I really have very interesting, episode and story about the ozone and global warming and related acid rain things, so that you can use it to your for your friends making, and also Okay, that is very important. The difference is absorption is inside, adsorption has occurred the surface. So the sponge actually suck up the water inside, So we call it absorption, not in itself. And adsorption is the surface phenomenon. So, for example, when you touch the oil can be adsorbed on your skin because it stays on your skin surface. That is the difference, right? Okay, any questions, any comments on the lecture? No? Well, the interactive story and episode will be continued next time. Thank you.